Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through Eulerian and Hamiltonian circuits. So we'll start with Eulerian circuits named after Euler, who we've come across already. But we're going to start with Eulerian trails. So remember that in a network, a walk is just where you visit a sequence of vertices. A walk becomes a trail if you don't traverse the same edge more than once. So a trail becomes Eulerian if we add this stronger condition that you must traverse each edge. So putting them together, an Eulerian trail is a walk where each edge is traversed once and only once. Now remember, our definition of circuit was that you start and end at the same vertex. So an Eulerian circuit for our purposes is just an Eulerian trail, but where you start and end at the same vertex. So it turns out there's really clear rules as to when Eulerian trails and circuits are possible. For a trail to be possible, there either have to be no vertices of odd degree or two vertices of odd degree. Any other number and an Eulerian trail is not possible. So for an Eulerian circuit to be possible, all vertices must be of even degree. So let's look at an example here. So we're going to determine whether an Eulerian trail and an Eulerian circuit are possible in this network. Now we can see here that 1 has degree 1, 5 has degree 1, 3 has degree 3, 2 has degree 3. In this network, there are 1, 2, 3, 4 vertices of odd degree. So that means neither an Eulerian trail nor an Eulerian circuit is possible. So let's look here. Let's look at the degrees of the vertices. So that's degrees 2. 2 has degree 3. This has degree 2, degree 2, degree 3. There are exactly 2 vertices here that have odd degrees. So that means an Eulerian trail is possible, but an Eulerian circuit will not be possible. So when you have this situation where there are exactly 2 vertices of odd degree, the Eulerian trail must start at one of the vertices of odd degree and finish at the other. So we're going to need to start the trail at either vertex 2 or vertex 3. So I'll just start at vertex 2. So if we start here, if we go 2 to 5 to 3 to 2, 1 and back to 3. This is an Eulerian trail because I've traversed each edge and I haven't traversed any of the edges more than once. All right, let's look at this last example here. So, to determine whether or not an Eulerian trail or an Eulerian circuit is possible, we need to look at the degrees of each vertex. Now, hopefully you can see here, A, D, B, and E all have degree 2, and C has degree 4. Every vertex here is of even degree. That means an Eulerian trail is possible, and an Eulerian circuit is also possible. So let's draw an Eulerian circuit. That means we have to start and finish at the same vertex. Doesn't matter exactly where we start. I'm just going to start here at A, go to C, B, then to E, back to C, to D, and back to A. This is an Eulerian circuit because I traversed each edge once, I never traversed any edge more than once, and I started and finished at A. All right, let's now look at Hamiltonian circuits. So let's look first at Hamiltonian paths. So remember that in networks, a path is a walk in which no vertex is visited more than once, but when it's a circuit, you can start and finish at the same vertex. So a Hamiltonian path has this stronger condition that you have to visit each of the vertices. So a Hamiltonian path is a walk where you visit each vertex once and only once. A Hamiltonian circuit is exactly the same, except you start and finish at the same vertex. So Hamiltonian paths and circuits are a little more complicated because unlike for the Eulerian counterparts, there isn't a very clear rule that tells us when a Hamiltonian path or circuit is possible. We just have to use some intuition. So let's look at this network here. if we want to go through a Hamiltonian path, we need to visit each of the vertices once and only once. Now, we're not going to be able to do that here. The reason is, if we look at D, E, and F, these vertices all have degree 1. So what's going to happen is, if I try and visit all of the vertices, I'm going to end up with a problem. I'm going to have to go to C, but if I go to D, I'm going to have to go back to C before I can visit E or F. There's no way that you can visit each of the vertices once and only once. So a Hamiltonian path is not possible, and that also means a Hamiltonian circuit is not possible. On the other hand, in this network, a Hamiltonian path and a Hamiltonian circuit are both possible. So let's look at a Hamiltonian circuit. So we can go starting at A to B to C, D, E, F, and A. So this is a Hamiltonian circuit. The reason is I visited each of the vertices. The only one I visited more than once was the one where I started and finished A. So this is a Hamiltonian circuit. Now, by definition, every Hamiltonian circuit is a Hamiltonian path. So all Hamiltonian circuits are Hamiltonian paths, but not all Hamiltonian paths are Hamiltonian circuits. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.